Hey guys, welcome to part 4 of using Firebase Firestore database solution with Unity3D for game development, or well, C# in general. So in our first video we covered introduction, overview, comparison, differences and pricing of Firebase compared to real-time database and MySQL. Then in part 2 we did some setup of our Firebase project, Unity3D project, and adding Firebase SDK to Unity3D. Then in our previous and third video, which was quite a long video, we covered how to add data to our Firebase database, how to uh, create documents, how to add data to documents, collections, etc., etc. And although that video was supposed to be about adding data and sort, we also covered in length about why you should use custom structures of your data, of your fields, why you should create custom structures with fields of your data types and field names, etc., instead of using Firebase examples of directly writing dictionaries like this or like this, and why or how it matters. And we also covered how to use constructors and methods inside your structures to make things easy and make life a breeze. Because believe me, the amount of time you spend initially creating these structures, writing these quick methods for your convenience, like that's all the time you're actually going to spend for this whole Firebase integration. Because after it, the actual calls to add or read or query data to Firebase are pretty simple. Like that's what we saw in our last video, and how we can use complex conditioning, nested data, and how we were creating like this kind of data where we have a field moves of dictionary type, and this dictionary has another dictionary, and that dictionary has moves, how to create numerical order of dictionaries, etc., etc. That, and like that is the main video that anyone wanting to like get used to Firestore with Unity should check out. So this video is supposed to be reading and retrieving data from Firestore, but because last video went and more or less actually showed and briefed reading, search query, nested data, we are going to merge all these three topics in this video itself. So reading data, Firebase provides this example where they create this nasty example. Actually they create a collection, create a document, add data to it, forget about it, just use our code, our example, how we did it in last video. Then this is their example of getting the data from your Firestore. So let's see what they do. They use the reference to our Firestore database, then they access the collection called cities, which is basically the table. Then they access the document named SF, and because they are actually using the name of the document here, SF, it means if you want to get the data or reference or retrieve data of a specific document, you need to know its name, the document name. And that's where the difference between why you should use proper names for your documents or use randomized strings like makes sense. Because if you are using randomized strings, you cannot get a copy of the exact document that you want to find or retrieve, because you won't know its name, it's a random string. So yeah, it's better to just uh, use custom names for your documents, which should actually be just the unique or primary field of your data. So user ID, match ID, etc., etc. Now let's see what they do. By the way, because they are using the exact name of the document itself, SF, they are telling grab a copy of the document of the data SF from our table, the collection cities. So in a roundabout way, they have actually already run a search query on our table of cities. Now let's see again. So this is pretty standard. I will post this in my blog. So this is a quick reference, a cheat sheet if you want to save it in your code as well. You can just run this, just use the reference of your database, FSDB in our case. Whoopsie. Well, I'm not going to save it anyway, so it doesn't matter. Just use a reference to your Firestore database, then access the collection that you want to retrieve data from, and use get snapshot async. Now, what they did was they accessed the document they want to retrieve by using .document and providing its name, and then they ran the get snapshot async on the reference of that document to get the data of that particular document. But what this will do, what this example that I have referenced here will do, it will get the entire data of the collection called cities. So whatever reference, whatever collection you provide here, and if you directly run get snapshot async here, it will get all the documents in that table. So for example, suppose if I had hundreds of users registered here and I directly ran get snapshot async on my users collection, I will get a like a result that will include all my registered users. And basically how these two approaches differ is that you do not need to run a query if your data set is small. You can just download all your data of the table of the collection in a single call. You do not need to waste your network traffic. You do not need to waste multiple calls. You do not need to make queries. You can just get all the users, 100 or 200 or 500, and then you can just use logic or conditions in your code to filter through that user. So even if I have a result of 100 users, I can just use a if-else loop to match the user ID manually in my code itself, looping through them. But if there were 100,000 or a million users, yeah, well, you're gonna toast your user's computational time, his device. So it's better to not use this. It's just for reference. Do not use this way. Well, unless specifically you want to get all the data instead of a particular document. So this is the proper way. Now let's see some real world examples. So yeah, I have this method get user in which I provide the user ID, and as you already know from before, I am using the user ID of my users as the document name. So it's like it will be unique because my user ID will be unique, and it's better for visual reference because I can know which user is which and which document holds the data of that user. So one way of doing it would have been, let's see how they have done it. So if I wanted to say, I am not gonna type this ID. So if I wanted to get say 123 user ID, I could do something like this. Use this example, and to rewrite it in our code, it would be something like FSDB. Actually, not even FSDB. We can directly use users because we already hold a reference to the collection called users in a property user. And this would basically get me a reference of this document called 123 because I already know if I know for sure that my document is called 123 or my user ID is 123, I can directly pass its value in this way, in the example that Firebase said, and then they use get snapshot async on document reference, and it will again run a async task. We get the reference of the task, we get the task dot result, which is the document snapshot, aka the document itself, and etc etc, and like then they are running for loop, and like again this is a bad and nasty and confusing example. The only way to understand any of the Firebase examples or code examples is if you start like uh, running them for your own use case, and like start modifying their examples to your own need or own use by hit and trying. So like it's better to do it this way. And what we are doing is we are not going to use their example to get a document, to read a document. Instead we are directly going to use queries. So this is the power of Firestore, where it triumphs real-time database, because you can provide multiple queries, you can compound queries, you can use multiple filtration statements in a single line of code. So the way to do it is like it's almost same as their reading document example, but this is how it goes. Create a object of type query, firebase.files.query, and we are going to use the collection reference of our users table, which we stored already, users dot where equal to. This is the query that we are going to use. Again, this was explained in more details in our last video, which was quite long and lengthy. And what it does is it says in our users collection, see if any document, no matter there are 10, 100 million documents, if any document has user ID equal to whatever we provided, and we are going to grab all, like this is query builder, we build a query here, then we use the query to get all the documents where this condition is met. So again, coming to our real example, we are not going to use document names like Firebase examples. This is, well, again, bad way, don't do it. Directly run the query on your data itself. So because we know for sure that, or at least in my case, my user ID is unique, and I'm running a query to find a particular user, say my user tried to log in, provided the user ID 123 or even username Siroyasa, my query will only result one user, return one user, because I'm trying to query or search on a primary and unique field, which I know it's unique across my users collection table. But say if I had a field called full name or city or country, and that can be like that, the value of that field can be same for multiple users. So even for this example, let's see, we have one user ID is unique, but username is Siroyasa. We have another user ID is unique 123, this is different user ID, but username is Siroyasa. So when we are running a query on the field user ID, providing a user ID to query on, we know for sure we are going to get a single unique result or no result at all if user does not exist. But if I was running this query on, say, username here and providing a string Siroyasa, we will get any amount of documents or results where the field username is set to Siroyasa, or in our use case there will be two results. So like this is how it works. Then we are gonna use query in other codes we are basically using the document reference, but here we just use query, and we use the get snapshot async method, pretty standard, same as set async. This is get snapshot async. Continue with on main thread, it will run this in asynchronous task, and we are gonna get a query snapshot task. So we are gonna get a task of type query snapshot, and this task has a result parameter which is of type query snapshot, and this is more or less like a document snapshot, you can say, but it contains another parameter document. And although we are like accessing it after multiple parameters, the main thing is this. So like let's go line by line. This is a debug code about this is a debug code and pretty useless. So we are gonna first see what will happen if we use the user ID field and supply the user ID 123, and because we know we have unique users, we are gonna get only one result. So first we check if query snapshot task is faulted. Basically, did we run into any errors? If we did, we can just debug log the error message. Again, in my case, this was due to rules, Firestore rules by default being set to false for read and write. Change it to true and you're done. And then we check if this is not true, our snapshot task is a success. Then we access the result and the document. So documents is actually the actual results which are returned, whether it's 0, 1 or 10 or million. And we check if the number of results we got were less than 1. So less than 1 means 0. If the number of results we got were 0, which basically means the user ID we supplied does not exist. There is no user in our users table which has a user ID that we supplied. So yeah, the user is not registered, user not found. But if documents.count is greater than 1 or even 1, then we know that we have some actual results, we have success. So what we need to do is this documents object is of type document snapshot, and it says INumerable of type document snapshots, which is more or less like an array. But the thing here is, because we know we are accessing a unique user, we are only going to get a single result. We do not need to run a for each loop or a for loop to access all the results, or we need to like create an array or anything. We just create a single document snapshot named user data. Then we access the results query snapshot task.result.documents, and we use this method first or default, which will basically result the first entry. So in our case, that's what we need because there is only one entry and we need it. So just use first or default. And if there were more than one entries, if there were 10 entries, it will still return the first entry, and which would be this one, because all the data would be returned numerically sorted. You can obviously provide some sorting if you want to, but we are not going to get into that. So we just print the user ID. We have a document snapshot, user data, user found, and document snapshot basically means this part, the snapshot of a document. And when you print user data.id, it means the name of the document, 111123 whatever, which is more or less same as our document user ID, but yeah, this will print the name of the document. Then we create a dictionary object of string and object type called details, and we convert our document snapshot to dictionary. And this is actually how I got all that idea of creating a structure and making my own method to also convert my structure to a dictionary. And same way you can even maybe convert your dictionary to snapshot or whatever. And so we have a document snapshot, the document, and then we convert the document to dictionary, and our dictionary details holds the it holds all our data, all our values, the Apple ID, FB token, all the fields. And as you see, I'm printing the username, so it will print Siroya. So I will play it in a bit and show you. So now the thing is, something which I have not implemented, and I will probably, is that in my custom structure, just like I have a method to convert my structure to dictionary, I'm going to create another method to send my structure a dictionary, this thing, and convert the dictionary to my structure. Basically, I will read the dictionary, all its fields and values, and using them populate the structure, my custom struct. So it will come handy in future, maybe. I'm not sure if I want to do it or not. Anyways, so this is if you have only one result, if you are querying or getting data that will only yield you one result or document. But say, what if I was searching for username? What if I used users were equal to username Siroyasa? So basically get me all the documents where username is Siroyasa, and all three of our sample documents have same username Siroyasa. So everything remains same. This count will print 3 because now we have 3 results. And so what this will do is it will only give us the first field 111 and not anything else, while this includes all the 3 results. So there are 2 ways to do it, or actually a few ways to do it. You could maybe do something like access a individual document using something like 0 1 0 1 2. So basically you can run a for loop with I is equal to 0 and I is less than equal to dot count, less than count actually, and you can access each individual document snapshot. Or you could use a for each loop, or there are ways to access multiple data. Well, the thing of importance is, if you are getting multiple results, you know you are gonna get multiple results. Do not use first or default, because it will give you only one entry. So in this case, for multiple results, your code will look like this, I believe. So this user data will become kind of an array which will hold all the results in it of type document snapshot. Then you can run a for loop, for each loop, or you do not even need to store it. You can do something like for document snapshot result in. You can directly run a loop like this, not even need to create any user data or any field. Just directly run a loop for multiple results. And that's about it. We have covered reading data, search query, nested data. Nested data was covered in much more detail in previous videos, so not really any use in this video. And in my testing, you can see I'm just calling the method get user, supplying it with the user ID, and I get the result. And that's all there is to it. We covered the fs head to move, which uses our complex struct with constructor and method to convert to dictionary, and a method to add moves, how to use nested data, dictionary inside field. And this is something I'm still working on. It is even more complex example. Maybe I will publish it on the blog later on. Not gonna make a separate video for this. And that's all there is to it. As you can see, it's pretty simple code, and just make sure you are using is faulted to make checks and debug logs during like development to make sure you are not running into weird hiccups, something I might not even have encountered yet. And like, yeah, that's it. That's how easy using Firestore is. And something I didn't actually cover in my second or third video was that when you are initializing these references to collection and providing the name of collection, if you provide a collection name that does not exist in your database, it will be automatically created. So right now you can only see 4 collections, and suppose if I add another code here for another collection, let's say testing, this will automatically create a new collection called testing. And yeah, that's it. So actually let me show you example of get user. Instead of username, let's print registration time. By the way, because I am running that do testing method from my start method, all of my testing codes are executed. Well, pardon me. And so moves updated. It added a new move, I think. Oh, it did not. It just overwrote the move because like we are running same IDs. Checking if user rating exists, checking if user exists, user is already registered. All of this was covered kind of in last video. Oh crap, we actually did not, in our testing method we did not uncomment a get user. So okay, here it is, the timestamp when the user registered, and that's just showing it works. Oh yeah, we added a collection, right? Okay, this did not work. Yeah, I now remember. Just like how if you do fsdb.collection.document and provide a document, it will not create the document unless you actually add some data to it, because it's actually a good feature. And that's because if somewhere somehow you forget a code like that in a loop or somewhere, it will not create empty documents. Same way, even if I add a code like that or these codes, these will not create any collections until I actually add some documented, in other words add some data in it. So there are no empty collections. And that's also why when you manually try to add a collection and you give it a collection ID or name, it will tell you to add its first document, and unless you add a document and some data, it will not create a blank collection. Kind of good design. uh, let's check another thing. So we covered this in last video, but just like how we are using get user as a separate method, let's uncomment. We are using a similar functionality in our add new user method, in which we run a query to check if the user with user ID we are trying to register already exists in database. So we create a query, we are checking on field user ID, we supply the user ID, and we make sure it's like the task completed successfully. We then check that the query we ran had less than one result. If there was less than one result, aka 0, it means no user exists in our database and we create a new user. If it's not 0, then that means we already have a registered user. And that's pretty much it. Yep, I did not skip anything, I hope. And like if there is anything more you want to know, more you want to ask, you can just leave it in comments. And if there is any help you want with your actual projects with your own use case, I will not directly like provide help or write code for you, but what you can do is you can just leave your use cases or questions in details in comments, and what I can do is I can just create a follow-up video addressing the issues, the comments, the questions of uh, actual users, and that way we can cover some things I might have missed and maybe even learn something more in the process. And that's all there is to it. As an extra homework, you can also study disorder and limit data, which is basically how you sort your results, how you limit the number of results you want, maybe 100, maybe 200, like first 100 users sorted by their name, etc., etc. And that's all there is to it. Rules you need to study and play with yourself, otherwise just use the standard rule. Just change from false to true in the default rules that are set in Firestore and you're done. Just you can visit my website, our website gamersdan.com, and get code samples from there to like boilerplate code from there to use in your own script and project and try it yourself. So yeah, that's it. And if you like the video, maybe like or subscribe, and I will make some more videos, especially maybe for multiplayer, using Photon to create turn-based multiplayer games, or follow-up videos for how I'm using Firestore. So goodbye for now. Enjoy developing. See ya.